Today I will talk about data modeling. And I know it's not an easy topic. It's not easy for different reasons. I think it's still something where a lot of companies either say, okay, we don't really need a data model. They say, we actually have a data model, but don't really have one. And then the third one, which is most interestingly, is people who use a specific way to model data and don't really like that other people use other ways to model data. When you talk about data modeling, there are sometimes some religious vibes coming with it. What is the right approach to model data? I'm at least guilty that I choose a clickbaity title for this video to claim there's an easy way to do data modeling. When I say easy, I mean lean. Lean means we just reduce specific kind of steps when we work on the data model. I will explain what I mean by that in the next 20 to 30 minutes. If you're still interested to learn why Event Data Model is a very good way to get started with data modeling, stay tuned. I will walk you through my explanation why it is a really good approach to get started and to have a very lean and easy data model that also scales pretty well. Stay tuned and follow me. This video is sponsored by Mixpanel. Mixpanel has a new way to do product analytics with your warehouse data. You can connect Mixpanel to your data warehouse, and then you can run all the product analytics investigations and all the product analytics deep dives on top of your data warehouse data with clean, prepared, and high quality data. Check out the link in the description to learn more about the offering. I'm using it and I'm extremely happy to have this new kind of setup for product analytics because it unlocks so many more use cases on top of much better data than before. Let's really start at the beginning. Why do we need a data model? There are books written about this, and there are plenty of books, and a lot of these books are already quite old books. But I think they're still worth to read it because especially the part, why do you need a data model, extremely well explained in this book. I give you now my version of my experience, but if you really want to extend this because you think I really need to have a solid foundation to know why we need a data model, I recommend to read any of the existing data modeling books. They're all really good and they explain a lot why you need a data model. Here is now my quick version why I think you need a data model. The first thing why you want to have a data model is, the first principle is don't repeat yourself. It's a common software development principle. If you always figure out that you write the same stuff in code all the time, in some point you start to abstract it and put it in a generic function and a generic class, and you just initiate it with different kind of parameters so that it does kind of the same job for, let's say, 10, 20, 30 different kind of scenarios. And I think this is true for a data model as well. Naturally, you can just dump all your data in a big database. Can be a cloud database like BigQuery, Snowflake, Databricks, whatever. So you can just dump everything in there, and then the analyst gets a question, hey, can you build this kind of report? Can you build this kind of dashboard? They go in, they try to understand where can we find everything. Here are the customer information, so I take this, and then maybe I take a little bit here from the orders, and so then I bring it together, and then I produce a final table that is then used by any kind of BI tool to visualize this. This is definitely a valid way, and if I want to get started, this might be the way to get started. But let's assume you have 10 of these people in your company, and they get 20, 30 different kind of requests from business, not just creating dashboards, but maybe also like make an analysis here and so on. And so they will start to repeat themselves a lot. So then they will, for example, clean up some customer data and all the models individually, and some does it a little bit different than the other. And so you by default create a mess. I already mentioned two things in this example that we should add here as well. Speed to insight is definitely one. When you have a data set up, you want to have the shortest way to an insight as possible. And so shortest way means is like someone comes up with an idea, a question, and then he or she gets an insight. The person can be the same who has the question, gets the insight, or they can pass it on to someone else and they basically give them something back so that they and then develop the insights. You can have different kind of scenarios, but in the end, you want to have this as fast as possible. I would say the ideal version is have a question, go somewhere, click somewhere, get my insights out of it. This would be the ideal. Usually, it doesn't really, most of the cases, doesn't happen like this, but at least like this is where you want to get to. The other thing is what I also mentioned is like because people define different kind of things is so, and I put it, it's data quality. And data quality is a huge topic. And it also includes the thing that I just mentioned is when you ask 6 people to in SQL define how you calculate a customer, you might end up with 2 or 3 versions of it. Just because like everyone, so you have to make decisions on the way. It might be decisions where you filter out specific types of customers, where you think, okay, they are not really customers, but maybe they are. In the end, you make up some business rules. And I say make up with a purpose. So you make them up. You make a decision on how do you define a customer. And you don't have to make the decision on your own. So usually, like I can highly recommend, is like to bring a lot of different people into the room and just discuss about it. Okay, how do we define a customer? And so, and let's say finance might have a different definition or than sales. But in the end, you really have to understand the differences between this, and then you have to find a common ground. And so it might be that in your model, you represent both. In the end, you say, okay, look, the finance definition of a customer is the core thing where we get started. But let's say for the sales report, re-enrich it with, I don't know, with this kind of thing. Then it's written down. And ideally, if you have a data model, it represents itself in the data model. So someone can go in there, check the SQL query that hopefully is documented in the proper way, and can actually see, okay, this is how we handle the customer. And so when they start to work with customer, for them, it's pretty straightforward to start. They can, for example, if you have really these 2 type of customers from a sales and financial perspective, they can first just make a decision, okay, this is a financial model, so I pick the financial definition and go from there. But they don't have to think about this anymore. So they already have some building blocks in there. They don't have to repeat themselves. They have good data quality because the metric of a customer matches the other one that is used in the other kind of reports. And of course, like they were using an agreed on business rule that where the company came together and decided on how they handle these things. And I think these are the 4 things where I would say why it really makes sense to have a data model. In the end, you just create a better result out of the work that you put into the data for the business team. So you increase the value of your work significantly. And this is like why I think it makes sense to invest into a data model. The next big question that comes afterwards is like, what data model? And this is, I already said in the intro, is like, this is where sometimes gets a little bit religious. Everyone has their preferences. Everyone approaches data modeling slightly different. Once, because they learned it that way. Second, because they made the experience that this works for them better. Because it's a design system. And so design, there's no right and wrong. You will come across star schema or dimensional modeling. You will come across one big table as a concept. You might come across data vault as a concept. And you might come across activity schema, which we will talk about today, as a concept as well. But again, like these are all different kind of concepts. And I also saw a combination of all of them to some degree because they all try to tackle something different. When I make a decision about a data model, and this is also like the reason why I was bold enough to claim to show like event data model is kind of an easy way to get started with data model. Let me introduce some measurements, how I look at the data model when I work with it, to say, okay, this one is really good to get started with, and it can grow a really long time. One thing that I look at is how many transformations. And this looks a little bit abstract, but especially when you already have some experience with, let's say, data models and working with data, every time you change the shape of the data to some degree, you always risk to make a mistake. Because things can go wrong. So you can forget something, you can join 2 different tables on the wrong criterias, you can introduce duplicates. With every kind of transformation that you do in your data model, you introduce the risk of making a mistake. And if you have a data model with 1,000 models that do step-by-step different kind of changes, so you have the chance of 1,000 times to do something wrong. And this can cause really issues, especially later when you really figure out at the end there is something off with this kind of metric. And we have to figure out why there's something off. And so I was in this scenario often enough that we recognize, so we look with marketing on specific kind of numbers, and marketing says, from a business perspective, this doesn't make sense. And so you are then there and you have to figure out, is it like this? Because it could still be that it makes sense. So sometimes business feeling is just like, because it's such an exception, that it's actually right, but you have to prove it. We often then came up in the situation where we really had to go through all the different kind of steps where we change the data from how do we ingest it and so on. We have to check on all the different kind of steps. Is there something that goes wrong? And I can tell you, like, if you have a lot of transformation, this is an extremely tedious work. Some analysis took us 3 or 4 weeks to really find out. And then in the end to figure out, okay, marketing actually was right. There was definitely something off, but we didn't really recognize before. Every transformation might be really useful because, like, again, you might imply all this, what we have up here. But every transformation always has the risk that something can go wrong. This is why I said treat transformations very preciously and with a lot of thought. So every transformation that you make, really ask yourself the question, is this a really necessary one? And should I really do this? So this is where I look at the data model. If the data model really comes up with a lot of transformations, it might still work, but I definitely have the risk implied that it can break more easily. When I look for a data model, I said like easy way, I look for a data model where I don't have to transform data so significantly. Then something else, it's a weird criteria, but how easy can I add new dimensions? Well, this is already pretty specific. In the classic star schema, we have fact tables, we have dimensional tables. We always have some kind of dimensional tables. Dimensional tables are context that explains a business object. So we have an invoice, and so around this invoice, we can collect dimensional data. So for example, like when this invoice have been created, when it has been sent, if it had an PDF attachment, what kind of amount this invoice had. This is all the context data that we collect around this dimension that in the end later helps us to create deeper insights. For example, we can then make a report to see, okay, how many invoices have been sent out without a PDF and with a PDF. All this different kind of context gives us different kind of angles how we can look at the data. And I would say, like in my work, when I work on data models, this is when we change things, these are usually like the parts that we change. So we introduce new dimensional values. Because someone says, look, it would be really interesting for us to understand, I don't know, if invoices sent on a Monday perform differently when they instead of sending on a Friday. Sounds a little bit absurd, but in the end, like for people who work operational, they might recognize, look, we really have a problem here with some kind of invoices not really getting paid in time. And it might be interesting to see if we send it out on Monday, if we maybe get paid more quickly. So it might be really some kind of the reason. So we have to introduce no dimensional values now. In this case, we have to introduce a workday as a new criteria. At least in all the work that I did, most of the work that we did was introducing new dimensions. And with the different kind of data models I work with, it was always a very different experience. I would say in the worst case, in the worst data model that I worked with, when we wanted to introduce a new dimension value, it sometimes took us 4 or 5 weeks to do that. Just because it was basically the same kind of here. We had a lot of transformations in there. We did not really decouple dimensions from the transformations itself, the worst case. So we introduced a new dimension at the beginning of the model, so basically at the raw level, and then we pulled this dimension through the whole different kind of transformation until we ended up in some kind of reports. And things can go wrong along the way, and they can go wrong. Really, like, this is a nasty thing. And also, like, we had to make sure that we pull this dimension through, I don't know, 20, 30 models in the right kind of way. It's a significant amount of work. If you really build a good data model, so you might abstract the dimensions away, or you handle them a little bit differently, that it makes it pretty simple for you to add a new dimensional value. And so this makes it really easy to do. The last one, time to get started. And this can be different kind of scenarios. So the first obvious one is like, so you get a new team member in your team and you want her or him to be as productive as quick as possible. So in DevOps, you have this metric, time to first productive commit, where you measure you onboard a new team member and you measure the time in average, how long it takes them to really make a commit that goes into production. It's definitely an interesting metric. It's also a difficult metric. Usually you don't really have a huge, big sample size. But still it gives you an indicator. If you always end up with 2 months, then it's definitely not really ideal. But it can have different reasons for this. It's always not the data model. It can be also like org reasons and so on. For myself, it's something different. I work as a contractor or as a freelancer for different kind of companies and work on data models. I switch between different kind of data models quite often, sometimes even within a week. So Monday, Tuesday, I work on one model, and then on the other days I work on a different model. For me, always like a good indicator how well a data model works for me is how long does it take me when I was off this model, let's say for 2 or 3 weeks, to get started again, to pick a task and say I want to do this. And so there are definitely some models, and they are the same like this, what we have here, where it sometimes even takes me a day or 2 days to actually get started. Because I have to sort things, I have to see, okay, this is how, okay, we do it like here, like this, and so on. And yes, you can handle specific things with documentation, but documentation just get you so far. I like a data model which uses a lot of standards, and standards in a good way, so it's not really limiting, but standards in a way that for me it's pretty straightforward to get started. That in the end I always know, okay, I want to do this, I find it here. I want to do that, I will find it here. And let's say also like specific kind of tables always follow the same kind of structure. For me, it's pretty straightforward to know, okay, which kind of columns I'm expecting. Long introduction. So we're already talking for roughly 15, 18 minutes to explain why we do all this. Let's get to the point where I think event data model is definitely something that ticks at least the boxes for me. And so when you listen to it, you might understand why I think that. When I talk about event data model, I basically will talk today about activity schema. I will admit you can use your own flavored dialect of event data modeling. In the end, so I use different kind of flavors of activity schema or of event data model in projects when it didn't really fit. Sometimes, for example, I still work on databases that don't support JSON columns, which activity schema is using. I have to find different kind of ways how to handle it. But the basic principles are usually always the same. How does an event data model look like? Usually what you have is like, you have one atomic event table. What this atomic event table has, I have one row per event. I have an event, I have usually like a timestamp, and I often have a unique identifier. It's not a must to have this unique identifier. I could also work without it. But the nice thing is if I have a unique identifier most of the time is something like a customer ID, a user ID, but it can also be a product ID. It can be a content ID or whatever. It depends a little bit on, well, let's say what kind of data you're actually looking at. Unique identifier is nice because it helps us to put things into sequence. And so we can build a sequence, what, let's say, a user does with our product over the last 3 years, step by step by step. This helps us to unlock more analysis use cases. It's not something that is super important when we model the data yet. It's super important later if we really want to answer questions like, okay, what are the top 3 emails that people receive that are helping us to convert them into subscription? This is where sequence analysis helps us a lot because like we can put at one point in time, people create a subscription, and then we can go back in time and see what kind of emails have they received and which kind of combination of emails show us a bigger impact on everything else. Doing this kind of analysis on top of a normal star schema data model is extremely painful and takes a lot of time, but you could build an event data model without a unique identifier. It will still work. The most important thing is like you have an event, you have a timestamp. So in the end, what we create is like a huge log file. One thing that activity schema does is it has a standard schema for this table. And so on, I will show you this when I show you the practical example. In activity schema, you always use the same kind of 5 or 6 columns to create this event table. And you often end up to say, okay, I create one event table per event type, or you create one for everyone. There are 2 different kind of approaches. They can be also like combined, so you can have one per different kind of event. In the end, you basically join everything together into one big table, because like then this one big event table enables you to create all this sequence analysis that you're looking for. But everything is built on the same kind of schema. We have an activity ID, you have a timestamp, you have an activity as activity name, you have a unique identifier that you often call customer, and then you have a feature JSON which holds all the dimensional values at time. This is another design principle. You don't have to do this. Most of the time when I build it, dimensions are added at the event time. What it means is I add all the dimensional values that are relevant for me at the point of time where the event is happening. I try to get as much context immediately there where the event is happening, because then I can get rid of all slowly changing dimensional tables that I have to hold, so I don't have to really historize dimensional tables anymore. It depends. I mean, I might still on a source level make history snapshots of specific kind of dimensional tables if I need to rebuild everything. But the principle is I place the right dimensional values right to the event, that when I later then do some aggregation, I don't have to do any kind of cross joins. Sometimes this is not possible, and there's a different way to design to still have dimensional tables, but just remove them from the events. So in the end, just have an identifier, then have the dimensional tables sitting separately. And then once you really do the analysis, then you join them back into this. But you separate them so that you can easily extend them without doing a lot of changes within the model. And then later you just join them back again. But I usually try to add the dimensions at event time. And the nice thing that it is already. In the end, when I create an event data model, so when we look at different kind of layers, I mean, data model usually has different kind of layers. So I still have a staging layer, or I don't know, bronze layer, or however you want to call it. Staging layer is basically like where I introduce all the different kind of data sources in my data model, where I do maybe some basic transformations. I make sure that the types are like I expected them. I define an interface how I expect the data to come in, which is a useful step because sometimes data sources can change. So I can use HubSpot as my CRM, and I might switch to Salesforce, but when I define my staging CRM model, how I want my CRM data to arrive, I can, but at least I can swap them predictably, and I can swap them in a good way. I define my schema how I expect the source data to arrive. And so this is what's happening in the staging layer. This is what's happening in most of the data models on the staging layer. So this is not a big difference here. And this also makes it so powerful. If you just want to add an event data model on top of your existing data model, this is how you do it. I mean, you usually already have a staging layer where you have all the data already there. And so you can just use the same staging layer that you use for your star schema and just build an event schema next to it because you just want to run some sequence analysis. This is totally fine. Then we have the middle part, which is the event or stream model. This is this kind of table what we have here. So I will show you this in an example. So for me, in my use case, I usually build out per event one table as a definition. So I build it, and then in the end, I join everything together in one table. And so this is what happens in this kind of layer. Because it has the standard schema and it's really broken down by different kind of events, it's super easy to extend. So when business comes around and says, look, we just introduced an onboarding to our product, and we have two significant onboarding activities. So onboarding gets started, and then someone watches an onboarding video. We then can say, we just introduced two new events here in our event model, which is like onboarding started and onboarding video watched. And it's super easy to extend this because in the end, it's just two models that we add here. Then we extend the stream with that. And with that, the data is already available for everyone else to work with it. After this comes the layer that everyone knows already, the presentation and application layer. And this just means is we take the data that we have here in a stream and we just make it ready for BI tools, for notebooks, for APIs, for whatever people want to use the data for. And this means we take the event data and we translate it into metrics and specific kind of dimensions in one big table. So maybe I don't know, or let's say sales team is using a specific kind of tool, and so we provide them. We just make specific kind of reports ready by just doing this. We can also build a star schema on top of that if, for example, we want to feed the data into Tableau or something else. The nice thing is like going from here to here, it's not so hard anymore, because going from an event data to, let's say, a metric is often pretty straightforward, because like you often either just count up the events or you create sums across events filtered by specific dimensional values, sums or counts or averages. In the end, it's pretty straightforward to go from here into, let's say, the presentation layer. And we end up with this 3-layer kind of structure. Even when you look at specific kind of DBT models where it's not really clear if it's a star schema or not, you might also end up with these high-level 3 layers. But in these kind of setups, this one is this big monolith in the middle that is doing a lot of crazy stuff, incorporating business rules and so on. And so this is something with an event data model, I can keep it extremely lean, because as I said, like we just introduce a new event or new activity and we just extend it like this. Sometimes as one extension, what I sometimes use, depending a little bit on the scenario, I add another business rules layer. And business rules means I can have a sequence of let's say, different kind of events, but I have specific kind of metrics that more complex to calculate than just do a count, a sum, or something else. One example is when I build an attribution model or different kind of attribution model. So attribution model builds on top of events. So we have an order and then we have marketing touch points before this order. Then we have an order again and so on. And so usually I want to know all the marketing touch points before an order. And then based on my different kind of models, I can then attribute the conversions and the revenue from this order to this marketing touch points. This is a more complex metric than just counting up marketing touch points or counting up orders. And so this is like why I introduce another layer where I then, for example, have one very simplistic model. It's a very simple one SQL query that just looks at the event data and then calculates the metrics for attribution, which is then used by presentation as well. Sometimes I extend it that, let's say I put complex metrics in this business rule area, but that's just one variance how you can do this. In the end, this setup makes starting with event data, with an event data model, extremely straightforward for me. Was also the reason why I tend now, when I build things, to end up with this, because I don't really have a lot of transformations. I do one transformation to say I want to accept the data, how it comes in a specific kind of format. I don't even have to do this. I could say, look, I'm fine. I don't really have to enforce this kind of schema. I can live with it. It doesn't change so often. I just do it because I often know in the future there stuff might happen. This is one transformation. Yeah. Then I have one transformation per event type. I have one model that I create per event type. And so in the end, my transformations only increase the more different kind of events I want to use. But this will not increase infinite. In the end, I might have 50, 60 different kind of events that I have here. Even if I have more, I can revisit if it really makes sense to have this. Business rules or complex metrics, usually I have 5 or 10 of them. It's not really much. So again, like 5 or 10 transformations. And then most of the transformations really happen here on the presentation layer, depending on which different kind of applications people use. But for example, in our example today, we are talking about we want to use the data in Mixpanel. And the nice thing is when I want to use it in Mixpanel, I don't need this, because Mixpanel can immediately build on top of that. Since Mixpanel expects event data model under the hood, I can then sync it up into Mixpanel. I can just build on top of that. And with that, I have reduced the transformation significantly. And it's super easy for me to add new dimensions, because like the dimensions are usually added to the event. If I take another product criteria, we have the product criteria here in the staging layer. I just go into all the different kind of events that need product dimensions. I have 5 product events. I go in there, I extend the information within the event as, let's say, as new dimensional or property values, and that's it. So easy. It's implemented in 1 or 2 hours. And then because like it syncs automatically up into Mixpanel, then it's already present. So I can basically introduce new dimensions within a day. That makes things. And time to get started, I have a standard schema, so I'll show you this in a second. So I have a standard schema here that I use. For me, when I want to introduce a new event, it's obvious what I have to build. So, and it's also obvious where I end up, because like I end up always with the same kind of schema. I think was the biggest revelation when I was starting to use this data model was whenever I took a break for 6 weeks when I was not working on the model and I started to work again, it took me 20 minutes to get started. I knew, look, I need a new source here. I add it here in the staging layer. Then from there, I can create a new event. So I did it here, and it always has the same kind of structure. And it's really straightforward to do this. This was a lot of theoretical background. Let me quickly show you one example in 5 minutes, how you can build this out and why it's so powerful. Let's have a quick look at an example project. I have one project here. So let's say we have a whiteboard application. So it can be Miro, here can be Excel Draw, whatever. We have a whiteboard application. And so the whiteboard application has different kind of events happening within it. And also, like in the end, people end up in the subscriptions. We have here, and we have some data that we collect directly within the app. We have two sets. So we have some data that comes directly as event data. So this, for example, like events board closed, this comes as an event data. So this, for example, can be data coming from Segment or Rudderstack, or it can come from, because you already have something like you use Kafka under the hood, you already have event data there because like you use it to run the whole application. You just have to ingest this kind of event data in your data warehouse in the source layer, and then you can build the staging layer on top of that. Interestingly, with a lot of companies I work with, they already have a ton of event data already coming in, which is at the moment either modeled away from events to, I don't know, weird forms, sometimes into dimensions, sometimes into facts, but it's already there. We can already tap into this. And then we might also have some, let's say, some static or snapshot data that is not in event form. For example, we have a table, invoices that we pull from our application database. So we have it here. The interesting thing is, like, I made a longer video about how you can take snapshot data and transform it into event data. I have a link in the description about this, how to do this. So we can take this kind of data that we have it here and bring it into event form. Because as you can see here, we have here period end, period start. This is basically like when the invoice has been issued and for which kind of period it's basically valid. And we can take the period start, for example, as a timestamp. Then we have the customer's identifier, and then naturally invoice issued would be like the event that we can derive from this. Or if we, for example, also have credit notes in there, we can just make two cases, one for invoice issues and then credit note issues. Even these snapshot tables have a lot of interesting sources where we can build events out of it. Okay, and so how would this look like? So just to give you one example. So here's a sample example building on top of the same kind of data source. We have a staging layer, as already said here. We define how we expect the data to come in. For example, we cast everything into the type that we are expecting. And again, this is optional. You don't have to do this. I always recommend to do this. It definitely makes sense to put on some expectations, how you expect the data to land within your model. Just also like to make sure if something breaks. It might be that stuff gets introduced in a different kind of type now, because you don't control how the data is loaded in your system sometimes. And so things can go wrong. This is your first line where you can check and make sure that things are happening as expected along the whole other way. This is the staging. Again, this is what you have most good data models, this kind of layer. And then we have the stream layer, which I just described here. So event or stream. And here, as said, we are building out all the different kind of events. And so, for example, here we are building events based on the snapshot data that we have. Maybe let's take subscription renewed is, for example, something that we build from the invoices. In this scenario, we just create invoices when a subscription is renewed. And so by that, we know when a new invoice is issued, it's a subscription renewed event. And so we can do this as an activity. And as you can see here, I was talking about the standard structure. When I use, this is based on activity schema, activity schema will always have these kind of columns. And so we always name it in the same way. This makes it really nice. It makes it also really nice to just combine all the different kind of events, because like we don't really have to think about, we just union everything here, because we know we always end up with this kind of model in the end. And this again, like makes it super simple if you haven't worked on it for a while, because you always end up with the same kind of thing. And so like another way would be now, we could now just get all the immediate event data in here. And then we would do the same thing. So we would just access the different kind of data. And then we would create another one, like what do we have? Board shared, for example. We would just create this. And what I really like about this, first of all, it's a pretty straightforward thing. The other thing is it's extremely easy to read. As long as you have proper event names, it's pretty straightforward for everyone what's happening here. And the interesting thing is like most of the metrics, so we haven't talked about metrics here, but in the end, this is what you create. You will create different kind of metrics. Just as a quick look. So let's say, so this might be a metric tree that we can use. So each kind of metric, so we might have a metric for how many boards have been shared, because in our scenario, boards shared gives an indication if people really get value from the product. So board shared, this is straightforward. Of course, like we need a board shared. We can take the board shared event, count it up, and we have the metric. Again, like new subscriptions here, of course, like we can go in here and we can pick the subscription created one. And with new subscriptions, it always comes down, let's say, to the time period. So if we look for the last 30 days, then when we create this kind of metric, we would take the subscription created, count it up, and then filter it down by, okay, the last 30 days. And that's it. So that's the nice thing. So when I have a good metric setup, the events that define the metrics are pretty straightforward, pretty easy to find in here. Because we name everything, how things are happening, it's often pretty easy for people to read this and then extend the model. Again, we can now go in, create the model for board shared, extend it to our whole stream. We would just add it up here. And then we can already make it available in any kind of dashboards. But as I already said, like we want to, if, for example, we make the things available in Mixpanel, then it's even like super straightforward. We create this new event model in here, then we go into Mixpanel. Mixpanel has now in every project the possibility to hook up to our data warehouse. So I connect my data warehouse here. So I have it here in BigQuery. Then I can go in here and then I can just add a new activity here. I have already 2 added. I could just go in here and can say I want to have a new event table. Then I point it now to the new board share table and have a new event in my Mixpanel data. I can just start to work with this. And this is the reason. So coming back and wrapping things up. So again, data modeling is a design decision. I make a design decision how my data model should look like. And with every design decisions, there is no right and wrong. It is up for revisit at least every quarter, every half a year. It always makes sense to look at your setup, what you have, and it's like, really, does it really work for this? I always check it for this. Do we have too many transformations? How easily can I add new dimension values? And how long does it take a new person to get started with the stack? Or how long does it take me to explain the stack to someone? The model that I showed you, I usually explain in 30, 45 minutes. So it doesn't really take long to explain. Based on that, you make your design decision. When I build data models, I nowadays always build an event data model. I might come across a scenario where doesn't really make sense. So let's say we always have just snapshot data or aggregated data. So let's say we have a scenario, we just have aggregated data. I'm not sure if I would really use an event data model here. Most likely not. But if I don't have it, and it's, let's say in the last 10 projects I did, I never had this. I usually always end up to create this event data model because it checks all the boxes for me. It doesn't have a lot of transformations. I can add dimensional values pretty quickly and I can explain it pretty quickly. And usually also when I onboard teams on that, for them it's pretty straightforward to work on top of that. They immediately get how the whole model works. And so this is why I claim that event data might be the easiest way to get started with the data model, but you can contradict me now. So I open it up. Please put it in the comments if you think this is not true. There are other ways to do it much easier, or maybe I underestimate event data. So I'm happy that if we have a lively discussion in the comments. Again, also if you have some kind of questions, just put them in the comments as well. If you check my channel, you will find some more videos about it where I explain how you can take snapshot data from your application database and turn it into events. Not all data already comes in the shape of events, but it's definitely possible to transform it in this. And it's not many transformations, it's one transformation. And yeah, if you like it, like the video, subscribe to the channel, and see you in the next video.